In this video, we're going to talk about working with text in Unix. So this is one of the things that gives Unix a lot of power. When we combine this with some of the utilities that exist with redirection and piping, we can do a lot of stuff from the command line without having to write a program to manipulate the data. So before I start, you'll notice I'm only going to use one window here. So I'm going to make this a little bigger so it's easier to see. If I do Control Shift plus, or actually it's just Control plus, but you have to get the shift to get the plus, notice the screen, the window I'm in gets bigger, and I can make it smaller with a Control minus. So I'll do that so that it's bigger for this video since we're only going to work inside the one window. So I've created a file and it's called class.txt, and this is a non-official list of just some assignments. And to remind you, there's a head command. So if I want the first 5 lines, I can get those. If I want the last 5 lines, or let's say 3 lines, I can get those. If I want to know how big the file is, I can use the word count command, WC, and it tells me that there's 9 lines. It thinks there's 9 words because it's a comma separated file. When we look at this file, you'll notice it's sort of out of order as far as the categories. So if I want to sort this by category, I can say sort class.txt. And you can see I get those in sorted order based on the first character. Now, suppose that I want to get just a listing of how many points things are worth. Well, you'll notice that's the second column in my comma separated file. So I can use the cut command, and the cut command, if I give it a delimiter, -d, and that's going to be the comma character, I can say that I want column 2, and I need to cat the file first and pipe it through cut. And I also don't want to do C, I want to do F because it's the second field, not the second column. It is the second column, but we call them fields here. If I say -C2, notice it gives me the second character of each line. And if I say 2 through 4, it gives me the second through 4th character. I can even say 2nd through 14th. So I can get any column I want based on characters or based on fields. So I could say 2 through 3. So 10 points for Linux, 5 points for Linux, and so forth. And now you can see I've created a file that has given me a different set of information. Now I can see how many points there are for each topic. So suppose I want to know what topics there are. Well, you can see that that's field 3. But you'll notice they're kind of out of order. So I can now pipe that through sort. And now, if I want to write a command that tells me all the unique topics that'll be covered, I can pipe that previous command through the unique command, and that gives me a list of the unique topics that'll be covered. So using that is pretty powerful. If I want to know what topics there'll be homework on, before I do this cut, first off, let's just grep for homework. Notice I'm using pipe again. And then if I want to know what topics, I know to do cut -d with a comma. The comma is the delimiter. I want field 3, and I'll pass it through sort and unique just to make sure that I get a list of just the unique topics, because that's what I'm trying to find out. And you can see now I have the list. There's homeworks on all 3. If I want to check quizzes, I need to say quiz because it's going to match the letter. So there's a quiz on everything. How about an exam? There's only exams on C and C++. grep has some pretty good functionality, and we've seen some of it already. Let's look at all our print statements in every C file. So you can see it gives me the name of the file. I'm going to use -n, Okay, so I can get the line number. Now, what I don't want to do is, let's say I don't want to see any of these lines that have STD in them somehow. So I can pipe that through another grep, and I can say -I for ignore STD. Sorry, that's ignore case. It's V. And that's going to give me every printf statement that doesn't have STD in it. Now, this is not just going to check for standard out, standard error. It would check for any time that string appears. So even if my string had some sentence that included STD in order, it would still flag that. So I used I previously. Let's grep the output of the printfs for length. Or let's just say len. We don't have any. But if we do -I to ignore case, then that'll match this line in functions.c. Okay, so let's take a look at another command that's helpful, and that's the find command. So if I want to find, there's a couple different ways I can do this. I can just say find and then give it a directory. And in fact, I'm going to give it the code examples directory. That's the GitHub repo. And if I do that, it's going to give me a list of all the files that are in that directory. Let's suppose that for whatever reason I'm interested in scheme. I can pass that through grep and then look for scheme. And there's all the files with scheme in their name that are in the code examples directory. But let's suppose I was searching for a specific file. Let's say I want to find scheme1.scheme. Or let's say I want to find all the README files. I think that'll be even more interesting. So I'll look in that directory, and I can give it the -n for -name. And the name is going to be readme.md. And it's not -n, it's -name. So there's all the README files that are in that directory. And notice it looks at every level. So here we have in scheme and then also in schemes subdirectories. We have C, C1, C2, and so forth. You can also look to see how old files are. There's a lot of examples. Take a look on Canvas. There's some links to some good examples. There's also some good examples in the notes. So review those. Find's a pretty powerful command. You can also use it to, for example, find every file that's say a backup file for your editor and then remove it. We'll talk about that later this semester, but for now, as long as you do find and then find -name, you should be okay. The one thing to keep in mind is find. If I say find readme.md, it's not going to find that because the parameter, the name parameter to find is the name of the directory you want to search. So if I say find devel, it's going to find every file in that directory. So to find something with a specific name, I have to say -name, and then let's say pointers.c. And so there we can see there's the pointer.c file. If I'm not sure what it's called, let's say I want everything with pointer in the name, I can say -name and then give it a wildcard. I need to put that in parentheses though so that the shell doesn't expand it. And so there's all the files that are related to pointers in that subdirectory. One thing also to keep in mind is the shell does expansion. So the reason we had to put this in parentheses, if I say echo point star, that's just point star. But if I say echo point star, that's a bad example. Echo D star, notice here I have these files or directories in my current directory. And so when I say echo D star, the shell expands this into whatever file names match that. So something just to be careful of, if you want to pass that to your command, you need to put in print into quotes so that the shell doesn't expand it for you. So the notes go into that in more detail